So today's topic is about Gauss law. Generally, we know the electric flux, formula for the electric flux, which is equal to electric field dot product with area. Okay, but in today's topic, we are going to consider a spherical surface. So this is the spherical surface. Here in this surface, you place at the center you place a charge, positive charge, and the radius of the sphere is r. Now you consider very small area, that is dA, infinitesimally small. That is, if this is the sphere, you are considering a very small, small area. So radially, the electric field goes like this, which is E vector. Then this small area is represented by dA. So this is for the electric flux at this point can be found out. But I want for the total surface of the sphere. In that case, what we have to do? We have to integrate this term, that is E vector dot dA vector over the closed surface. The closed surface we assume to be spherical. So that's the idea. So when the charge is at center of the sphere, the electric field is everywhere normal to the surface and constant in magnitude. That is, this, if you draw a tangent at this point, this will be normal. Now if you consider this point a small area, electric field will go like this, and small area, so dA vector will go like this. See, everywhere it will be constant, the magnitude will be constant, and it will be radially outward. So I told you for this point, if you consider dA, so E vector dot dA vector. If you consider for the whole sphere, then you have to go for integration for the closed surface. So that's what we have written here. So phi E is equal to E vector dot A vector. If you go for the closed surface, this is represented for closed surface, E vector dot dA vector. This is a dot product. Therefore, integral over the closed surface, here it is sphere, which is E dA cos theta. Now, the electric field lines and they are perpendicular to the area vector is both are in same phase, same direction. That means the theta is angle 0. So dA vector and E vector, both the direction lies in the same, the direction is same, therefore the angle is 0. So theta is 0, cos 0 is 1. So this value will become 1 now, and E is taken outside the integral. So phi E is equal to E vector integral, closed integral into dA. Now we know the electric field is given by the formula 1 divided by 4 pi epsilon naught q divided by r square, and the area of the sphere, so integral the small area dA, you have to add all the areas. That means we are integrating. So finally, what will be the area of the sphere? The area of the sphere is going to be 4 pi r square. That is integral dA over the closed surface, which is assumed to be spherical. It is 4 pi r square. Now phi E is equal to E. You substitute for E, which is 1 by 4 pi epsilon naught q by distance square. Here the distance is r. So distance square is r square multiplied by the area of the sphere, which is 4 pi r square. This 4 pi gets cancelled, this term. So finally we have the flux, total flux is equal to Q, the charge, divided by epsilon naught. This is Gauss law. Or stated otherwise, phi E, total electric flux, is equal to integral closed over closed surface, here it is spherical, which is E vector dot dA vector is equal to the charge enclosed inside the sphere divided by epsilon naught. Now if you consider different shapes, where there we are considering a regular shape of a sphere, But even if you consider for different shapes, say here you have a sphere A1 with the surface area A1. Here you have some irregular surface. The area is A2, and finally third here also A3. It is irregular shape. So you are considering different areas. First one is uniform, whereas second case and third case is not uniform. So the electric flux lines comes out in all the direction. So the net electric flux is same through all surfaces. It is not going to vary. So what do you infer from this relation? That is, if you want total electric flux coming out of the surface of a sphere, then that value is equal to the charge enclosed divided by epsilon naught. What is the epsilon naught? Epsilon naught is the permittivity of free space, which is given by 8.854 into 10 power minus 12 farads per meter. Thank you.